students, I am Dr. Nimi Singh. Today, I bring you the next learning episode on a very important unit of the paper Criminalistics, that is Forensic Significance of Soil. Dear students, in today's lecture, you will be told about the soil and how is it important as an evidence. In addition to it, you will also be studying about the composition of the soil. In this lecture, you will also get to know about the collection, preservation and handling of soil and how their examination is carried out. We will then wind up today's lecture with the conclusion. So, let us have a look at the modules which we are going to learn today. So, the first one is going to be a brief introduction to the soil, then how soil can be used as an evidence, the composition of the soil, and then the collection, preservation and handling of soil, examination of soil, and then in the end we are going to conclude with a summary. Is nothing but a complex and changing mixture of decaying organic matter, living organisms and minerals, weathering rocks and decomposing plants. It is a natural body divided into horizons of loose, that is unconsolidated minerals and organic matter of variable depth on the earth's crust, which is capable of supporting plant growth. Soil can in general be considered as the natural accumulation of the humus, sand and gravel. The formation of soil is actually a dynamic process influenced by multiple factors like climate, geological parent material, biological activity, relief and time. Soil may develop after being deposited by water, wind, human activity or animals or in situ. Soils are usually formed by the decomposition and disintegration of rocks and of the vegetation and animal fossils embedded in them. Rocks, they contain innumerable minerals which on weathering give soil particles in which various organic minerals from animal and plant resources or plant sources get mixed together and form soil which is usable for different purposes. A soil is a 3D transferable natural material which is found on the earth's crust and provides natural medium to plant growth. Their properties are due to the persistent action of climate and the constituent living organisms. Soil is actually formed from rocks in two stages. Firstly, decomposition of parent material by weathering of rocks, and secondly, the development of soil profile. Mud and loads of dust are sometimes found on vehicles or suspects' shoes. Although soil is quite different from other types of trace evidence, it is still going to serve the same purpose. So, here the basic question would be whether the soil came from the crime scene or not. Although collecting soil sample from the shoes is easy, but the choice of control sample is rather difficult. This is due to the fact that soil is a dynamic accumulation of particles constantly changing over very small distances. Soil sometimes varies within inches across the landscape and within inches down into the ground. Primary known samples are chosen from the spot where the question sample originated, such as location of shoes, tire prints, etc. A thorough analysis is then required to determine whether the two soil samples have the same origin or not. So, for this, methods like density gradient and observation of physical characteristics is used. Coming to what is a soil horizon? A soil horizon is a parallel layer to the soil surface whose physical characteristics differ from its adjacent layers. Each soil type is generally made up of 3 or 4 horizons. Horizons may be defined on the basis of obvious physical features, chiefly the texture and color. These may be described by one of the two approaches, that is in absolute terms, for example, particle size and distribution of texture, and in terms relative to the surrounding material, that is a sandier or a coarser than the adjacent horizons. Now, coming to the layers of soil. Soil is generally made up of texturally and visually distinct layers, but from forensic point of view, generally only top two layers are important. So, we are going to discuss here only the two top layers. In the figure, the soil horizons are shown. Now, you have organic matter. It is a superficial organic deposit with litter layer of plant residues in non-relatively decomposed form. So, then you have is a surface soil. Now, mineral matter mixed with organic components. It is the layer of mineral soil with soil life and the accumulation of most of the organic matter. This layer is depleted of aluminium, clay, iron, other soluble constituents and organic compounds. Although there are vast variety of soils in the state, each type may exist for a few yards or a few feet with a large amount of variation even in a single soil sample. Hence, to exactly pinpoint the origin of a particular soil sample is often not possible, but it is rather easy to relate it to the areas of its occurrence. As a function of depth, nature of soil also varies vertically. Soil changes are also very sensitive towards human activity and nature. Debris originated from industrial operations and human habitation form an integral part of soil. The latter type of debris, for example, bricks, fragments, cinder, chemicals, paint, droplets, roof, shingle stones, paint chips, glass, fibers or other items, if sufficiently unique and varied, can be most valuable factors in determining the individuality of a specimen. Soil samples with such unusual features can actually prove to be excellent physical evidence and may strengthen a link between the specimens consequently. Now, the composition and character of soil not only varies with depth, but also laterally. In most of the cases, generally the superficial layers of the soil are examined unless there is a crime like digging of a grave. However, the changes of texture and colors of soil are not that much morphologically visible along the ground, but its chemical composition can show a variety of changes even in a very short distance range, and it actually helps in accurately determining the source of the soil sample. Therefore, in order to determine the normal distribution of soil of a particular crime scene, sufficient soil samples should be submitted. Coming to what we call as impressions. Now, ensure that impressions in soil such as footprints, tire marks or any other patterns are photographed by keeping a scale nearby to take the dimensions of that print, and a cast of plaster of Paris is made before in any manner disturbing the footprint. Photographs should be taken with a camera keeping it perpendicular to the impression. This will actually prevent the photograph from angle distortion. If the soil is firmly affixed to any object, it should not be removed. Such objects must be air dried then and properly packed in a paper bag or an appropriate container along with proper sealing and labeling. Clean paper envelope should be used to pack loose sand or soil sample, which can later be sealed in a suitable container and labeled as to source. Coming to the composition of soil. Soil is a part minerals, decaying organisms, water and air, all in varying amounts. Soil texture, it actually describes the size of the mineral particles that make up soil. There are three main soil grain sizes: sand, silt and clay. Sand describes the largest grain size and clay the smallest grain size. There are also three subcategories of soil: loam, peat and chalk. Loam is a type of soil which is made up of sand, silt and clay. Along with mineral particles, soil can also contain organic materials such as decaying plants and animals. Soil with more than 20% of the decaying organic material is what we call as the peat soil. Chalk soil is alkaline and contains various sized pieces of solid but soft rock called chalk. Coming to the collection, preservation and handling of soil. To the nature of soil, it is mandatory that the exact location of the collected sample should be properly documented, be best illustrated by hand-drawn sketches or detailed commercial maps. Questioned samples, which are generally taken from ground-like samples taken from the gait pattern of a shoe, should be compared to the control samples collected from similar places, that which is according to the law of comparison. Further, because the factors affecting soil formation are time governed, timely collection of evidence is also very important. To ensure that examiners have adequate information of the variety or the variability of soil, sufficient number of control samples should be collected from the crime scenes along with the surrounding areas. Establishing the resemblance of a particular sample to a specific location greatly strengthens the association between them, excluding the possibility of others. Of course, the available amount of suitable soil can also limit the level of significance of comparison. In any case, the amount of questioned sample available for analysis cannot be controlled, but the investigators can substantially control the number as well as the amount of known specimens collected. All samples should be dried before packaging, sealing and labeling. Moist samples should be air dried first at room temperature for overnight before packaging. Along with this, the collection of control soil samples should not be overlooked. Control samples should be collected from the area that could be claimed as a probable source of questioned soil. A suspect may, for example, claim that the soil collected from shovel that was used to dig the victim's grave actually came from a garden. On forensic analysis and comparison of both the samples, the dissimilarities of both these samples can actually eliminate the yard or garden as a possible source. Now, questioned or suspect samples. A tablespoon of soil may be sufficient for a soil comparison. However, if the questioned sample is available in a larger quantity, then the control sample should also be collected in equal quantity. The larger the quantity of soil sample, the more specific will be the comparison results. Control or comparison samples. Now, obtain the samples consisting of at least 3 tablespoons of soil from each area which are suspected to be associated with the scene of crime. Control samples must be representative. If, for example, a pair of suspect shoes are recovered bearing a soil sample, the area of the footprint will correspond to the soil location on the shoes. While forensic soil examinations can yield important information concerning crimes and can establish the absence or presence, whatever it may be, of a link between criminal victim and the place of occurrence, proper handling and collection of the evidences by the investigators definitely affects the successful results. By understanding the vulnerability of earthen materials to contamination and by adopting the suitable collecting and packaging procedures, the potential forensic value of soil as an evidence can actually be maintained by the investigator. Its composing particles, which vary greatly in the sizes. So, the soil particles have been divided into various groups which are termed as separators. Following are some important physiochemical properties of the soil. Coming to the soil texture, the mineral component constitutes the largest volume of soil mass and plays an important role in determining most of the physical characteristics of soil. The relative percentage of different soil separates sand, silt, clay is called soil texture. Soil structure is described by the shape, size and grades of soil particles. Now, the density of soil represents the weight of the soil per unit volume as grams per cubic centimeter. The degree of compaction and soil makeup greatly influence the density of the soil. Now, coming to the soil pH, that is the nature of the soil, whether it is alkaline or acidic, is determined with the pH of the soil, which is given in the table. Now, the first is going to be the denomination, that is whether it is alkaline or acidic, and then the pH range. If it is ultra acidic, then the pH is less than 3.5, extreme acid between 3.5 and 4.4, very strong acid between 4.5 and 5.0, strong acid 5.1 to 5.5, moderate acid 5.6 to 6.0, slight acid 6.1 to 6.5, neutral it is going to be between 6.6 7.3. Now comes the alkaline nature with pH as following: slightly alkaline will have pH 7.4 to 7.8, moderately alkaline 7.9 to 8.4, strongly alkaline 8.5 to 9 and very strong alkaline greater than 9. Coming to the soil color now. Soil color is inherited from its parent materials. Often, soil forming process also influences the color of the soil and is termed as acquired or organic color. Now, coming to the methods for soil analysis and comparison of soil samples. Soil is a complex mixture of both inorganic as well as organic materials. During a soil analysis, the class characteristics of several soil samples from a known source are compared with those of a question sample. Just as with all items of evidence that simply contain class characteristics, exclusion is actually possible when the class characteristics of the known samples do not match with the question sample. If the crime scene location is not known, a questioned soil sample may hold information which is associated with its location. A trained forensic chemist familiar with the local geology may offer assistance in identifying regions containing soil with similar class characteristics that may potentially be the scene of crime. When soil samples and related items are forwarded to the forensic science laboratory, qualified examiners conduct soil examination and compare two or more specimens in order to determine if the soil can actually be linked to a common origin or not. Laboratory personnel conduct the examination by comparing the texture, color and composition of the questioned and the control soil samples, as these characteristics are an outcome of locality dependent factors and are very sensitive to a number of factors. Deviation in the characteristics tend to dissociate two samples under examination. Therefore, sufficient number of samples along with proper documentation and collection procedure greatly increases the chances of associating soils to a common origin. This in turn can prove to be a valuable forensic evidence to associate or disassociate suspects with a particular scene of crime. In order to find a link between suspect and the crime scene, the forensic investigators most of the time find it beneficial to compare the soil samples found at the crime scene with a sample on the suspect's clothes, shoes, house, etc. For this, a thorough analysis is required to determine whether the two samples have same origin or source or not. The various methods for soil analysis are as follows. The first is the microscopic analysis. A soil analysis begins with a visual examination of several known samples. The natural variation of color, texture and general appearance are recorded. The color of the sample must be analyzed when it is both wet and dry, and all visual similarities and differences must be recorded. The stereoscopic microscope magnifies the microscopic surface features of the sample, aiding in the identification of vegetative matter that leaves common to the area, paint chips indicating soil found close to a barn or house, sawdust, bone chips or any other minute items which are not even visible to the naked eyes. This is achieved by illuminating the surface of the sample with the reflected light of the microscope. A polarized light microscope is actually helpful in analyzing the internal features. This process involves oscillating electric fields of plain polarized light that propagates in a single direction. The light is produced by introducing a special filter called a polarizer in the light part between the light source and the sample. As the plain polarized light passes through the sample, it interacts with the sample in ways that can be measured through careful examination. For example, uniform lattice structure is a characteristic of crystalline solids. Because the minerals found in soil are frequently crystalline solids, this microscope can be used to determine mineral content, which in turn serves as a class characteristic of the entire soil sample. Coming to the particle size distribution, the individual particles in soil samples, they vary widely in size, hence it is often troublesome to determine the complete size distribution of a sample through visual or microscopic analysis. So, in this case, the soil sample is made to pass through a series of sieves, containers with a mesh or screen bottom, where the size of the mesh on each sieve differs. They are stacked together so that the sieve with the coarsest mesh is on the top and on the bottom is the finest mesh. The entire stack is manually or mechanically shaken for several minutes. The mass of soil retained in each sieve is then compared to the total mass of the sample that was introduced into the stack. The distribution of soil mass due to the particle size is considered to be a class characteristic of the soil sample. Then comes the density comparison. Density is the ratio of a substance mass to its volume. Both the questioned and the known samples should be collected by following the similar procedure. For example, if the questioned sample taken from the bottom of a suspect shoes is suspected of originating from the surface of a muddy field, then the known samples should be collected from the muddy field surface and not dug from the ground. Density is typically expressed in units of grams per milliliter or kilograms per liter. It is a physical property of a substance that does not change with amount. Chemical and physical properties of this nature are actually intensive properties. Extensive properties such as mass or volume expressed independently change as a function of amount. For example, as the amount of a glass sample is increased, both its mass and volume will increase, but the density will not. Density is commonly used in forensic science when comparing items of evidence such as glass, plastic, wood and soil. However, because soil is a complex mixture composed of many substances. Each substance will have its unique density. Ideally, the forensic scientist will use the density gradient method to evaluate the distribution of densities comprising the soil mixture. Now, a density gradient can be prepared by carefully adding solvents of varying densities to a glass container like narrow glass tube or a graduated cylinder. Often bromoform 2.8 grams per milliliter and methanol 0.791 grams per milliliter are used to create the gradient, with pure bromoform on the bottom, pure methanol on the top, and decreasing bromoform methanol mixtures from bottom to top. Because substances of a lesser density will float on top of substances of greater density, the gradient described is quite stable. It is important to recognize that substances of a greater density will obviously sink in substances of a lesser density, and substances of an equal density remain suspended in the solution. If an unknown soil sample is poured into a density gradient, each substance comprising the soil sample will sink until it reaches a region in the density gradient where its density matches that of the gradient. A visible profile of the distribution of densities of all substances found in the soil sample is obtained in this way. The profile of a questioned sample can be compared with the known sample to determine soil type. In this method, a cylinder is filled with various solutions in such a manner that at the bottom is the solution with highest density, while at the top is the solution with lowest density, and in between the density gradually decreases from bottom to top. The soil sample is then placed in the cylinder. The soil will sink through the solution with higher density until it reaches the place where its density matches with the density of the solution. At this place, the soil particles, they will remain suspended and thus create bands in the solution. The bands will represent the varying densities of the particles marking the soil. Sample solutions from same origin will produce similar bands through this method. This is due to the reason that the large deposits of soil have a uniform composition in regards to the percentage of various particles, and density of each type of particle is always same as the density is an intensive property. Thus, a sample that the forensic investigators collect from the crime scene and a sample of soil which is found on the suspect's clothing can be compared by this method. If both the samples have the same origin, then they will certainly show similar bands, but if they show different bands, then they are indeed from a different origin. Qualitative observation of physical properties. Let us come to this now. Soil samples can also be analyzed with the help of qualitative observations which are based on sensory details and not mathematical calculations. In other words, the two samples can be compared on the basis of color, texture, particle shape and mineral composition. The color of the sample can be viewed simply with human eyes itself, but both the samples should be at the same moisture level, as moisture can also alter the color. For this, the scientists usually heat the samples to dryness or add excess moisture to both the samples so that their color can be compared accurately. The texture of the soil depends on the ratio of the sand, silt and clay, which are based on particle size and not the chemical difference. Regarding the shape, soil particles have angular, sub-rounded or well-rounded shapes. The figure on the screen shows the different shapes of soil particles. In order to carry out examination based on the mineral composition, the forensic investigators use a microscope to determine the make. This is quite a reliable method, as color and shape of a mineral is quite distinctive. If all these physical properties match, then they are said to have the same origin, while if these properties do not match, then they do not share a common origin. Now, coming to the pH comparison. pH is defined as the negative logarithm of hydrogen ion concentration in an aqueous, that is the water solution. When mixed with water, many of the compounds within a soil sample will produce hydronium ions. The amount of hydronium ions produced depends on the composition of the soil. So, soil pH is commonly determined by a forensic scientist during a soil comparison analysis after moistening the soil with a predetermined amount of water, often 1 part of the soil to 1 part of water. The pH of water extract of the soil is tested using pH indicators, litmus paper or a pH meter. Soil pH is a class characteristic which is used for comparison. Let us now conclude our lecture. Naturally occurring soil is a complex and changing mixture of decaying organic matter, living organisms and minerals, weathering rocks and decomposing plants. Soil has immense evidentiary value. It can help link a victim, suspect and the crime scene. Soil examiners are required to work carefully to prevent it from getting contaminated and such that their evidentiary value is not lost. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.